Okay, in this video I'm going to go over the node voltage problem that showed up on exam 2. Okay, so what we do with node voltage is we look at a systematic way of solving for the node voltages in a circuit. And what this allows us to do is to analyze a circuit pretty easily once we have these node voltages. Furthermore, it's systematic in the way that we come up with these equations, and so it gives us a good framework for solving and analyzing electric circuits. All right, so that's the motivation. So what we do here is we write KCL equations. So let me write that down. KCL equations at each node. Okay, so let's consider node VA first. All right, and the way I work this is I put all the currents coming out of the node. All right, so here's a current I1. Here's another current coming out of the node I2. And here's a third current coming out of the node I3. All right, so we've taken care of all the currents coming out of node VA. All right, so from there, what you need is to push, I call it pushing the dots, all right, to where you get the voltage difference across an equivalent resistance so you can calculate a current. Okay, so I'm going to say that again. Push the dots till you get a voltage difference across a resistor. It doesn't count for a voltage source or a current source. Those don't help you at all. You need to get a voltage difference across a resistor. All right, so mentally what I do, I'm going to take this first circuit and blow that up in purple. All right, so I have this circuit and I have plus minus 40 volts. And what I do is I combine that into an equivalent resistance between the node. All right, so here's VA and here is the reference. Okay, I have 2 in series with 10 to give me 12 ohms. All right, so now I push the dot. All right, by that I mean I know this voltage is, with respect to the reference, is at a value VA. Okay, so I push this dot. This is still VA because I'm just going along a wire. On the other side, because it's plus to minus, this would be VA minus 40. All right, remember it's a lot like elevations. If you have a drop in elevation, you just subtract that off relative to where you are before the drop. Okay, so because it's plus to minus, this is VA minus 40. All right, so this dot of the resistor on the top of the resistor is VA minus 40. All right, this dot would be the reference. So we take the reference to be 0 volts. So I push that dot to the other side of the resistor. All right, 0 volts. And now I have a voltage difference, plus, minus, for the resistor. Okay, I always use a passive sign convention. Okay, so that would mean that I1, I always use a passive sign convention for a resistor, I should say. That would mean I1 is the plus, VA minus 40, minus the minus, okay, plus, minus, minus. Okay, I wrote down the minus 0, even though that's kind of trivial. You don't have to write that, but you get the idea. And then I divide by 12. This is simply Ohm's law, all right? So I've manipulated Ohm's law to give me the current. All right, so good. I went in great detail on that, but what I do when I write node voltage equations is I can look at node VA, and without writing down I1 plus I2 plus I3 equals 0, I can just simply write down by inspection each of the currents. Okay, so the first one, it's VA minus 40 divided by 12. All right, the next one, okay, this one's much easier. When I look at this node for I2, I push this dot would be VA, and this dot would be VC. So this would be VA minus VC divided by 3. Okay, and then finally, I can break out this current I'm sorry, this circuit. All right. And I know that that would be equivalent to this, where I take the 6 and the 8 and combine that to a 14. All right, so there's VA, and here is VB. Okay, so what would this current be? Well, you push the dots, so if this is VB, this would be, on the other side here, VB plus 20, right? Here's this dot, that's at VB. I go minus to plus, I get VB plus 20. Now I have two dots on either side of an equivalent resistance, so I can calculate the current. Okay, and the way I have this referenced, all right, I3 is moving this way. Here's I3 moving this way. This must be plus minus, okay? So VA minus quantity VB plus 20 divided by 14. Okay, so that's all of node A. And remember, you have to write an equation. This is equal to 0. All right, so here's the node voltage equation at node A. All right, let's do node B. All right, so for node B, this dot would be VB. This dot would be 0 plus 10, so that's a 10. So I would see VB minus 10 over 4. Okay, then we have this current coming out this way, which would be VB minus VC over 7. And then finally, this current coming this way, which is similar to the circuit I just got through doing, only I'm moving the current in the opposite direction. Okay, so that would be, looking at this picture over here, if the current's moving this way, you'd go plus to minus, so it would be VB plus 20 minus VA divided by 14 equals 0. Okay, so there's VB. And finally, VC. Okay, I'm going to change the colors here because we got a lot of going on this page. Let's make this blue. All right, this current plus this current plus this current equals 0. Okay, so for this first one, okay, we have VC minus VA over 3. Okay, for this one coming down, VC minus 0. Yeah, one dot minus the other dot. VC minus 0 over 5. And then finally, this direction would be VC minus VB over 7 equals 0. Okay, so those are the equations. That's all I asked you to do. With the idea that, I included this down here. You can put these equations into MATLAB and solve them, or into your calculator and solve them, and you'd be able to analyze this circuit. All right, so that wasn't part of the exam. I just wanted to show you that this can be done systematically.